Software Engineering Radio, episode 120, OCL.
This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for support.
So, Anneke, welcome to our show.
Thank you.
As is customary, please introduce yourself to our audience.
Yes. Hello, my name is Anneke Kleppe. I've been involved in the UML 1.1. That was actually the first version to be specified as a standard. And I've been also involved in the development of the Object Constraint Language, also known as OCL. And I've also did some work on MDA, ModelDriven Architecture, and currently my focus is on Domain-Specific Languages.
Okay, clear. Well, you mentioned OCL already. Could you tell us a bit more about your whole involvement with OCL? How did this thing get started?
Yeah, well, I've been working with object-oriented modeling from the early 90s, and I was very familiar with what is now called the class diagram.
Yeah.
And, well, it seemed to be that you couldn't express everything that you wanted and needed to express about an application in that class diagram. And now I'm not talking about dynamics, things you put in activity diagrams or state diagrams, but more the static things that you'd like to add to class diagrams, which are also very important, like the age of a person may not be less than 0.
Mm-hmm.
Very important stuff.
Typical
when you
stuff.
talk to database administrators, they'll always know what you are talking about.
Yes.
So we decided to find a way to add a way to class diagrams to specify these types of what we are then called constraints. So it's actually really something that is restricting the class diagram so that you have few instances which are actually valid.
Mm-hmm. Yeah. So, I mean, what were your influences in creating OCL? I mean, did you start from scratch? Were there already existing stuff that you got inspired by?
Yeah. Of course, we were inspired by what was previously available. We were inspired first by the work in the programming language Eiffel,
Mm-hmm. Oh, yeah.
with the pre and post conditions
Yes.
and invariance. We were also inspired by the programming language Smalltalk,
Mm-hmm.
in the way that you can build expressions.
Yeah.
And we were also inspired by the work that was already done in IBM at that moment on business process modeling, business
Mm-hmm.
modeling. And in IBM at the time, people thought it was very important that business people should be able to express these types of constraints in the way that they really meant them, in the language that these business people use.
Yeah.
And from these 3 starting points on, and of course the UML class diagram, we created a language, and of course all type of background stuff like set theory from mathematics and things like that. Actually, everything we had in our package we took into account in building the OCL. And I keep referring to we because I did not do that alone, but I did that with my colleague Jos Warmer, of course.
Yes, yeah. You mentioned the IBM initiative that was targeted at enabling business people to come up with the constraints. Was this a target for you as well when you started out together with Jos working on OCL?
No, not really. this has been a dream in IT for so many years,
Yes.
for 40 years or so, to have the business people express what the application should do.
Yeah.
And I really don't believe in that. We will never be there. But we do need simpler ways to express these type of things, because the business people require more and more complex things to be expressed.
Yeah.
You know, in the 60s, when people started to think about, well, business people should write programs, then the programs were so simple that indeed, if you had a mathematical background, you could write programs. But now the demands on IT are much higher. And we need to express more complex things. So the IT people need new languages to express the business stuff in a better and more efficient way.
I guess this subject will pop up later when we talk about your current activities.
Absolutely.
You mentioned Eiffel and Smalltalk as an inspiration, but OCL ended up looking differently from those languages, no?
Yes.
Because is there a reason behind that? The reason why I'm asking this, because I think that generally, and I'm not hoping I'm treading on any toes here, but people tend to find OCL difficult, more difficult than they probably tend to take Eiffel or Smalltalk, for instance. And is that due to the influence of the set theory that you mentioned earlier, that you infuse that on the language?
Yes, it probably is. The ideas we took from Smalltalk was that you can put one expression after the other using a dot notation, and so you can build a very, very large expression. And every expression needs to have a resulting value to be able to do that. And when you combine that with things from set theory, like take the subset of this set, but leave out half of the members based on some expression, then you really get this complex, well, what people find complex notation nowadays. But actually, it's not a very complex one if you really look at it. It's actually very similar to SQL, only SQL is more, you have to write more when you write SQL, and OCL is a very condensed language.
SQL is more of a narrative language. It is like you're writing a story, more or less. Maybe that helps people in, because I've always been confused by the relatively lack of uptake on OCL and the relatively large uptake on SQL. People that were more or less proficient in SQL were not so in OCL, and I was always bothered by that. This indeed could be a phenomenon. Yeah,
it's a very condensed language, but there's also another difference between SQL and OCL, and that is that, well, SQL really takes the godlike position, if you like, from the object-oriented point of view. You know, everything is available, everything is visible, and OCL takes an object-oriented point of view. You come from a certain object, and you can see within the context of that object some stuff, and then you navigate through all of the data that you have. So that's also a very important difference, which people tend to find difficult.
I can see that. So all in all, how would you describe the influence of OCL? Are you happy? Did you succeed in what you set out to do?
Yeah, I'm happy with OCL. Absolutely. It is taken up, especially by the academic community. Not so much in IT practice, I think. But maybe that's one step too many. But it does influence thinking about languages. For instance, in Java 5 you have the collections that are typed by the element type. Well, OCL had that a long time before. And I really believe that the requests for those typed collections come from people who had a look at OCL and thought, well, that's a good thing. We really like that, and we need that.
Do you still see a future for OCL, or has the window closed?
I see a future in OCL, actually, as I've always done, not in the language itself. The language itself will probably die in 10, 20 years.
As languages do.
As languages do. But I see a large future in the concepts that we introduced. Working with these collections is very easy in OCL, and you see that again in Java 5 there's a much simpler way of expressing loops over collections, iterations over collections. You also see that in C#, by the way. And stuff like that, bits and pieces from the ideas of OCL. If only the constraint aspect, the notion that when you have a database schema or a class diagram, that you really need to have something else which restricts that diagram to valid instances is very important, and I see a large future for that. Yes.
Yeah. Okay, that's clear. Are there any areas nowadays where you think it should be applied but isn't?
Not specific areas, but I would like it to be much more applied. If only for building simple, if not to say stupid, UML models.
Yeah.
Everyone who builds a UML model should also regard OCL as a useful tool.
But tool support, especially in UML tools, is lacking with regard to OCL, isn't it?
Yes, I'm surprised about that, because it's really very simple to build an OCL parser and to give some tool support in these UML tools. Yes.
Have any idea why that is? Why tool vendors just don't seem to see the value that OCL could bring to UML modeling?
No, I don't have any idea other than it's not very demanded by the clients.
Yeah.
So it's actually, there's no demand for it and there's no push for it. There's no pull and there's no push.
Yeah.
And so it's only there in small parts of the IT world where people really see the use of it.
Yeah. And of course it has popped up in some reincarnation in the QVT standard by OMG as well.
Yes, of course.
So that has been an influence as well, I guess.
And in open architecture, where in the Czech language.
Yeah, which is inspired by OCL, I guess.
Yes.
It's not OCL itself, isn't it?
It is.
It is?
It is.
Oh, I should be embarrassed not be knowing that. There's some stuff I should be editing out. So in hindsight, would you have done some things different, looking back?
No, I would have created the same language. Yes.
That's clear.
Absolutely. No, it's not completely true. What I would like to add is more dynamic stuff to it.
Mm-hmm.
And you need only to have a few things, like to be able to instantiate an object. And, well, actually, if you are able to instantiate an object in an OCL expression, then you are already much more powerful.
Mm-hmm.
So stuff like that, I really should like to do that.
Yeah.
Yeah.
Okay. Let's close the subject on OCL and let's move to your other historical contribution. The first book on MDA I ever read was by you and Jos Warmer and Wim Bast, I believe.
Yeah.
So let's talk a bit about UML and perhaps MDA. Yeah. Could you tell us a bit about your involvement with the whole MDA thing?
Mm-hmm. Yes, of course. Well, as I said, I've been involved in object-oriented modeling for a long time. But object-oriented modeling doesn't bring you an application.
Yeah.
You need to do something by hand. And I've seen so many programmers and UML modelers struggling to do that. That already in very early stages of my career, I thought, well, you should do this differently. You should really automate the transition from model to code. And with the MDA, this possibility became a reality. And I've seen that before, already in the early 90s. I've seen that done, but only for very small niche domains. And with the start of MDA, it appeared to be possible for not only these niche domains, but for a very large group of applications. And that's why I became so actively involved in model-driven development.
Were you actually involved with the whole OMG definition of MDA, or were you just writing the book?
No, I was just writing the book. Yeah. But of course, through my context with the OMG, I did have their information. And some insights on how they looked at it. But of course, I didn't always agree with them. I actually don't like the distinction of the PIM versus PSM model.
Yeah, that's my favorite pet hate as well.
Yeah.
I mean, if you want to spend numerous time-wasting discussions, let's discuss the whole independent and dependent stuff and that whole pattern.
But of course, everything is dependent upon something.
Yes.
So actually the question is what is a platform? And I don't think the OMG has clearly defined the notion of platform.
You also wrote you also wrote a book about UML, I believe.
Yeah, a Dutch one.
So were you also involved in the UML definition by OMG?
In the very first stages, UML was created first by Grady Butch and Jim Rumbo at Rational. Ivan Jacobson didn't join them, but later on. So that was version 1.0, and actually version 1.1 was the first to be standardized. And I did some work on that. I wasn't in the core team, but I had some influence, I hope. At least my name is on it. So
yeah, that's a good thing in itself, I guess. So how would you characterize the impact of MDA, being a person who has been involved with MDA from the fairly beginnings?
The impact of MDA is that now not only a few people know that you can generate code from a model, but actually a large amount of people from the whole of IT industry is aware of that. And I don't see that a large amount of people are really doing it.
Still not.
Not yet. But they are aware of its possibility, and they are not as reluctant to experiment with it as they were 20 or 15 or 20 years ago. And that's the good thing, I think, about that's a good thing about MDA.
So it raised the awareness of the whole concept and the whole ideas you just mentioned.
Absolutely.
I can see that.
Yes, and I've always said, well, it's a matter of generations. It takes 20 years before MDA really gets into the grain of the complete IT industry. But I think we are well on our track. Yes.
So that's a positive note.
Absolutely.
Okay, super. Because are there also things that you think that should have been handled differently in the whole MDA creation?
Yes, I think the expectations were too high too early. And that's actually what I mean by saying, well, it takes a generation before this technology really is ingrained in the whole of the IT industry. That means that, well, you're talking about 20 years or so. And you can't expect to have all of the advances of MDA within the first 3 or 2 years. You really have to wait these 20 years before you get all of the good stuff out of it.
And you have to go through a whole cycle of tools coming to the scene and maturing to a level that people can actually use them.
Yes,
And that's,
exactly.
So we are still halfway on the hype cycle, so to say, in your opinion.
Or maybe not yet halfway. We have a few years to go yet.
Okay.
Yeah.
That's a promising thought.
Yeah.
And the same goes, I guess, the same line of questioning for UML2. I mean, you were involved with UML1.
Mm-hmm.
How did you like or experience the creation of UML2?
Well, UML2, the specification, or building the specification, I only experienced from the outside. We were doing the OCL standard at the time,
Mm-hmm.
and we were actually waiting a very long time before the UML specification to be finished. And in fact, we already finished our OCL specification a long time before the UML specification was completed. So what I saw from the outside was a large number of discussions which I thought weren't really useful, and the result is a very, very large specification.
Yes.
Which I find is not the best thing that could have happened to the world.
Yeah.
I should have preferred a much smaller and much more concise specification.
Yeah, that is already answering my next question. I mean, as a UML1 and MDA practitioner, or even visionary, how would you characterize the quality of UML2? Is it useful enough?
Well, that depends on which side you're on. From the point of view of a user, UML hasn't changed much from 1.0 to 2.0.
It's a good thing, yeah.
So you could say that's a good thing because it's backwards compatible. But you could also say that it's not a good thing, but because we don't have enough new elements in the language. The language doesn't evolve much.
Yeah.
So I don't think that's a very positive effect, actually. I tend to be on the side, well, we don't have enough evolution in the language. From the other point of view, you can look at the specification and say, well, is this a good way to express this language?
Mm-hmm.
Well, I didn't like the UML1 specification very much. It was too vague.
Yeah.
It was incomplete. It was inconsistent at some points. So it was really a good thing that they changed that. But the resulting standard, the UML2 standard, is, as far as I'm concerned, too large and too complex to do anything with. Now, if you only look at the levels of inheritance hierarchy, sometimes you have more than 20 levels and of subclasses. From my knowledge of object-oriented modeling, you shouldn't have more than 3 or 4 levels of subclasses in a good object-oriented model.
Yeah, as a rule of thumb. Yeah.
As a rule of thumb, exactly. And that for me means, well, something's dodgy about this specification. Another example is the relatively large amount of different classes for things which are only barely different. If you look at actions, for instance, I believe there's 18 or 20 types of actions. I don't see a large difference between these actions. Actually, the difference is not large enough to really amount to so many different meta classes.
Mm-hmm. Yeah.
You should have modeled it differently.
Yeah.
But that's coming from my experience with object-oriented modeling and the stuff we've learned from that.
Yeah.
So on these two items, from the user point of view, there's not enough evolution. From the specification point of view, the specification is too complex and it's too large. I'd say, well, if we really want a UML 3.0, we have to take a completely different direction.
Yeah. Do we want a UML 3.0?
Well, UML is a success, and it's a good thing to build upon that success. But only if we can evolve the language.
Yeah.
And at the moment, I don't see any new developments in modeling languages that I think are worthwhile incorporating in the UML.
Mm-hmm.
But that also tickles me on the bit of domain-specific languages,
Yes.
of course.
Yeah. Perfect cliffhanger this.
Yes,
Yeah.
of course. And because domain-specific languages do not need to be general. UML, of course, needs to be general. It's a unified language.
Yeah.
And in a domain-specific language, you can incorporate much more specific stuff, which is useful for a special domain, but not in general.
Yeah. So what is looming at the horizon in terms of domain-specific languages and the technology involved in that?
Well, looming on the horizon are a large number of domain-specific languages, but all really small ones.
Mm-hmm.
And perhaps that's a reason why we don't see them. They creep in, as it were.
Yeah.
Because there are already a large number of domain-specific languages. But they're small ones, they're used in one company or in a small domain. And they don't get worldwide attention like the UML.
Yeah.
So that is what is... It is already over the horizon. It's coming.
Yeah. It's actually, we can actually see the horde coming.
Yes,
Yeah.
absolutely.
Stampede.
Yeah, it's like a stampede of small domain-specific languages. And the reason why we don't recognize them is because each of them is so very small. It's a stampede of ants.
Yeah, stampede of ants, yeah. But of course, it's kind of the essence of the whole thing, that they are kind of small, that they are very specific to a domain, or even a company's interpretation of a domain, right?
Yes, right.
So that
That's true.
would that nullify the need for a universal modeling language or a unified modeling language, in your opinion?
No, I don't think so. Because I think there are commonalities in every industry, in every IT domain.
Yeah.
And we need some way to express these as well. And programming languages are, of course, a good means to do that, but they are a bit too low level.
Mm-hmm. Yeah, absolutely.
So I really think that UML and domain-specific languages can live next to each other.
Okay. Really didn't think about that scenario. But of course, that would mean that there would be a universal mechanism of actually communicating between language and language instances, right? The promise of MOF, for instance?
No, it's actually a misconception that MOF or EMF can help you there. MOF and EMF and any meta language is only capable of expressing the specification of a language, but it's not capable of expressing how languages communicate with each other. Or actually, I should be more precise with that, because it's not how languages communicate. Languages do not communicate. It's the programs and the models, or as I call them, the programs of a language that have relationships with programs in another language. And to be capable of having these relationships, you should build your domain-specific languages in a very specific way. And currently there are no explicit things, explicit concepts in the meta languages, in MOF and EMF that is, to express these interrelationships between programs.
So what do we, you talked about it a bit, but what concrete technology is there that can be a role in this field if MOF and EMF aren't?
That is something that we still need to invent. And of course, there is some history on this issue as well. because already in the 70s and 80s we were capable of linking in libraries in another language within programs in a specific language like C, for instance. And we can build on that. But nowadays we need not only include libraries, but we need to really relate to programs or programs in two languages. And we really need to have new technologies for that. In my upcoming book, I will explain some of the stuff that I've invented to do this. But I'm sure that there are many other ways to do it, and many of these will prove to be more effective in the years to come.
Okay. You mentioned the terms already a few times, MoGrams, described in your upcoming book. Can you tell us a bit about the book and what it is all about and when it will be released?
The book is at the publisher at the moment. It will be released in about 4 months. And it's the title is Software Language Engineering. So it's really on what a software language is. And for me, a software language is any language that we use to create software with. Not natural languages, but any artificial language. So because they're artificial languages, really we need to explicitly specify them and explain them to people. And of course, any software language has an abstract syntax and a concrete syntax and semantics, like any language. And for a software language, these semantics could be either a code generator or a virtual machine. So that you can run these MoGrams in this virtual environment. And actually my book is on that, how to explain, how to specify abstract syntax, because that's really the kernel stuff of a language. The abstract syntax is the most important thing. How to express concrete syntax in various forms, textual, graphical, or a combination of both. How to express the semantics of a language. What is semantics really? Because for many people this is a very strange word, semantics. And I also address the early stages of how you of the technology of how you can communicate between MoGrams, how you can interrelate MoGrams. And actually this interrelationship is something that you see all the time in programming languages. You have a UML model is just one large chunk. It's one large piece of, it's not code, it's a piece of model. But in the coding world, we've left this type of things a very long time ago. We've noticed that it's much more simple and it's a much more practical way to do things in small bits and pieces, which you interrelate with each other. And we should do that on the modeling level as well. We should have smaller bits which interrelate. And the new thing here is that we could also interrelate things which are written in different languages.
So really chunking up your problem in several chunks that operate with each other, and all those chunks can be written in different languages, right?
Yes. And every language you choose, because it's a good language to express that type of problem in. So you could have a language which expresses the screen flow for a web application, and you could have a language which expresses your database structure. Well, we have several of these, of course. But we should relate these two to each other. And in that view, I also see a place for the UML next to these large amounts of domain-specific languages. We could also use UML, but only for very specific elements of software development.
For instance?
I find that the class diagram of UML is very convenient to build, domain schemas in.
Yeah.
But that's only part of an application.
Yeah.
And there are several other bits of UML which are more or less useful. It depends on what you really want to express in your application, what type of application you have.
So it really is picking out the good stuff, the stuff you need for your particular aspect of the overall problem.
Yes.
That's the gist of it, right?
Yes.
So would that then enable our age-old dream of getting business people on board? Would this be an opportunity for that age-old dream?
Yeah. No. I believe I said this earlier, but I don't think we will get business people to do the programming for us. Programming, building software is really a very specific task, and you should be schooled for that. You should be educated in doing it. But we should be able to bridge the gap between the ever-rising demands of the business and the application level. And as far as I'm concerned, currently I see that the demand side on the business side, the rise of the complexity on the demand side is much larger than what we are capable of delivering on the IT side.
Yeah.
And that's actually what I see as a real problem.
And is there anything in what we talked about in this interview that could help us in alleviating that problem?
Well, I think domain-specific languages are the way to go. Yeah. Currently, there is no other solution for this problem than domain-specific languages. Bringing the language of the IT people much, much more closer to the language of the business people.
Yeah.
And these two languages will be different because the business people will never have the formality that we really need in the IT.
Yeah.
But we should be able to bring the two languages much more closer together.
Yeah. Just to bridge the gap that nowadays exists. Yeah.
Yeah. Make the gap as close as possible.
So it's the most easiest to jump over the gap.
Right. But there will always be a gap. That's because I find that gap is necessary. You have to have people that are really not formal and just brainstorming away and doing their stuff, the business that they're good at. And you have these more formal people that are really taking these ideas and building the applications based on them.
Yeah. Well, on that note, having said that, maybe we should conclude with you expressing your fears and hope for our noble trade for the foreseeable future.
Mm-hmm. My hope for the trade is that the developments will be quicker to reach the average IT developer. Currently, I see that there are many people out on the edge doing MDA, domain-specific languages, and much more interesting stuff that we have not discussed during this interview. And what I find is that the knowledge of these people on the edge doesn't come through to the average IT person.
Mm-hmm.
And we should really be aware that what we know should also be brought back to the people to help them in their day-to-day business.
Yeah. Is it the same gap that is between IT and business, like we talked about earlier?
No, it's a different type of gap, because in this case, both sides have the same formality.
Mm-hmm. Yeah.
Only the one does it in the traditional way, the way that person has been doing it 10 or 20 years. And for many IT people, it's difficult to keep up with all the new technology, and that's why they tend to be a bit conservative.
Yeah.
And they hate all these new things, even if they appear to be interesting and cost effective, like MDA and DSLs.
Yeah. Was this the hope or the fear you're expressing now?
Well, the hope is that we will be able to get through to these average people, and the fear, of course, is linked to that, because the fear is, well, no, we will not be able to get all of these good stuff really used by everyone in the IT business.
Well, on that note, I think that's a fine moment to bring this interview to a conclusion. Thank you very much for your time and attention, and thank you.
Thank you.
Thanks for downloading and listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example by clicking on the Dig, Reddit, Delicious and Slashdot buttons. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under a Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the PodSafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.